Okay, let us start with a new concept under the second chapter. So, in the previous class, we have understood how to solve or how to find out the DFT of a given sequence using DIF-FFT method and DIT-FFT method. Now, in this class, we'll go for efficient computation of DFT of two real sequences. So this is what we call it as application part. The question will be something like, if you have a sequences of two n-point sequences. So two n-point sequences, let us assume x1 is one sequence of n-point sequences and x2 is another n-point sequences. But here, instead of using n-point and n-point two times, so if I want to find out the DFT of this, then you should able to calculate x1 of k and then once again x2 of k separately, right? Now the point is it not possible to compute the DFT of x1 of n and x2 of n using single discrete Fourier transform? Using single, which means that you should apply or you should perform DFT only one time, but using those value you should able to find out the value of x1 of k and x2 of k. That's how combining x1 and x2 in this particular topic we make the efficient computation in such a way that instead of applying n-point DFT two times, we apply n-point DFT only one time, but we try to obtain the x1 of k and x2 of k separately. Okay, so that's the agenda of this particular topic, and we'll see how we follow this method. Okay, so what we do is we try to combine this x1 and x2 in such a way that I can write this x1 and x2 in the form of x1 of n plus x2 of n, j times x2 of n. So I have tried to treat this as a complex number, though it consisting of only real numbers, but we try to combine them and make sure that it is complex conjugate, complex value, because you know that if you see here, the point is very simple. If there is a 8-point DFT, as I told you, if you find a first four DFT values, then rest of the DFT values are just a complex conjugate, right? You already know this concept. So hence what we do is, using that as a fundamental concept, what we try to do is we combine the two real sequences, and I'm giving you the hint, it is real sequences where x1 and x2 will not consist of any of the numbers which comprises of imaginary. It is purely real number or real sequence. Now what we do is we combine them, x1 and x2 are combined in such a way that it gives me a complex value sig. So that's what we represented using x of n. X of n equal to x1 of n plus j times x2 of n. So what is DFT of x of n? It is nothing but, what is this? It is nothing but x1 of k plus j times x2 of k, right? Now see, x1 and x2 can be calculated in such a way that, just observe here, is it, you already know this the fundamental the trigonometric function, where if I write x of n is equal to or if I say z is equal to a plus ib, right? A plus ib, you know how to find out the value of a and b, right? So that's where by using by a and b are calculated by using z and z complement value, right? So which means to say that if you know x of n value, you can obtain x1 of n and x2 of n in such a way that x of n is equal to x of n plus its conjugate divided by 2, and x2 of n is equal to x2 x of n input x of n and its conjugate, both are subtracted divided by 2g. So this is how the imaginary part x2 and real part x1 are going to be obtained back. So using this concept, we try to write the x1 of k and x2 of k now. See here, x1 of k and x of k is nothing but x1 of k plus j times x2 of k. Now, with the same concept, is it not possible for me to find out this? Yeah, that the same thing. Use how do you find out the x1 of k now? X1 of k is nothing but your input x of k plus x conjugate of n minus k, because it is periodicity property, divided by 2. What about x2 of k? How do you find out? See, you need to find out x2 of k by using x of k, right? So what we do, x of k minus its conjugate, that is x conjugate of n minus k divided by 2g. So this is how we try to obtain the DFT of two real sequences. So look at this and analyze this properly. See, if at all I want to apply, if I want to apply the traditional method, so for this n-point DFT and for this one more n-point DFT are supposed to be employed. Now look at this. If it is n equal to 4 point and n equal to 4 point DFT, how many complex additions and complex multiplications are required? Is it not? So this is where we try to combine this to get a single, see, a single n-point DFT. So which means computation of, here it is, computation of two n-point sequences using single n-point using single n-point sequence. So what we did, there are two n-point sequences. We obtained its DFT, or we obtained their DFT using single n-point DFT. So this is how we say that the efficient computation of DFT of two sequences. Now we will try to solve one simple example here. Please let me know if there is any disconnections. Okay. Sometimes will not be coming to know. Okay, thank you. Now we will try to solve the one simple example, and we try to understand this particular concept in much better way. In the examination also, if you ask to explain, or if there is a kind of theoretical conceptual question, where how do you compute two n-point sequences using single n-point, so then yes, of course you need to mention all these mathematical equations, followed by, it is always better to take a simple example and then explain it. Okay, now here is one such example. Determine the DFT of 4-point DFT of two real sequences that is g of n and h of n. So instead of giving x1 of n and x2 of n, so in the explanation we took it as x1n and x2n. Here we are giving the problem in the form of g. That's it. Gn and hn. G of n is equal to 1202 and h of n equal to 2211 using single 4-point DFT. Okay, now what is the first step? I should combine x of n with g of n plus j times h of n, right? So x of n equal to g of n plus j times h of n. Okay, if I combine those two, what will be my x of n sequences now? 1 g of n. G of n is the first sequence, n equal to 0. What will be x of 0? X of 0 is nothing but first sequence of this one plus j times first sequences of this one. So therefore it is 1 plus 2j. Next, the first sequence, that is first sequence of g of n, that is 2 here, that is 2, and the first sequence, that is 0th sequence, here it is first sequence, n equal to 1, n equal to 1 of h of n, that is 2 plus 2j. Okay, then similarly I write x of 3 and x of x of 2 and x of 3 values. Now this is the combinedly I call it as x of n. I hope you got a clear idea that how do we write x of n by combining g of n and h of n. Very simple and straightforward here. Now what we need to do? We need to obtain the x of k, because I need x1 of I need g of k and h of k. I need g of k and h of k, but I should calculate using single endpoint. What we do is very straightforward, in a very simple way. We calculate x of k from x of k. From x of k, we try to obtain g of k and h of k. That's it, right? Okay, now we try to calculate my x of k values. So very simple, we already know this technique. Can you tell me what's the answer for the DFT of x of n? So this is, I wrote a matrix here. So this particular point everyone knows it, and it is well versed concept as far as for you guys. Can you tell me what is the output for this problem quickly? Just so the final answer is 4 plus 6j minus 2, plus 2 minus 2, then followed by 2j. So now what we need to do, once we got about the values of this is x of k, right? The value x of k is obtained by obtaining the simple DFT calculation. Now see here, we applied 4-point DFT only one time. Okay, else in the traditional method, if I want to calculate g of n and h of n, so we apply 4-point DFT for this g of n, and one more time 4-point DFT for this h of n. But here we combined both the signals in the form of complex valued signal. Then we applied a single 4-point DFT, and we could obtain the x of k values. Now from x of k values, we are supposed to obtain the values of g of k and h of k. So that is my second step. So first step is over. This is, I call it as step 1 or first step. Now the moving to the second step, where we know the definition of x1 of k and x2 of k, which is nothing but In this case, it is g1 of g of k and h of k here. That's it, right? So in this case, it is g of k and h of k, not x1 and x2. Huh? Now, how do you obtain? So very simple. So now obtain g of k. What is g of k? Quickly solve this. G of k is equal to x of k, x plus x conjugate of k. Let me have this reference. And uh, and and before to that, I need to obtain the uh, I need to obtain x conjugate of n minus k. How do you obtain x conjugate of n minus k? So in this case, n value is 4, right? So n value is 4 and we try to put n equal to 4 in case of x of n minus k. Now just go on substituting the value of k equal to 0 first stage. That will give you 4 minus 4 x of x conjugate of 4. What is x conjugate of 4? We don't have here x conjugate of 4. We don't have x of 4 itself, right? So which means what will be the usual x of 4 value? What will be the x of 4 value? It is nothing but since it is a periodic in nature, it has to repeat x of 0 itself, right? So it is nothing but I need to conjugate my x of 0 value here, right? So therefore it is 4 minus 6j. And here once again, let me change this is 4 plus 6j. So here the answer is 4 minus 6j for x conjugate of 4, first signal when k equal to 0. Now when k equal to 1, it is x conjugate of 4 minus 1, that is 3. So here x of 3 value is 2j, therefore x complex conjugate will be, its complex conjugate will be minus 2j. Then further putting k equal to 2, it becomes x complex conjugate of x conjugate of 4 minus 2. It is nothing but x conjugate of 2, and there it is minus 2, and it remains same. We have in rest of the both the cases we have real numbers. So therefore here even for k equal to 3, it is x conjugate of 1, it becomes 2. Now we have x conjugate of k, right, which is nothing but x conjugate of n minus k. X conjugate of n minus k equal to 4 minus 6j minus 2j minus 2 plus 2. And we have x of k here. So we have x of k here, and we also have x conjugate of n minus k. And now the process is very simple. Add these two, divide by 2, we will going to get g of k. Subtract these two, divide it by 2j, we will going to get h of k. Please guys, do it fast and obtain the values for g of k and h of k further. Do it. Now I don't have the answers, so you should help me out, right? So g of 0 is equal to what? X of 0 plus x complex conjugate of 0 divided by 2. Perform this and let me know the answer. Quick. What is the value of x of 0? So x of 0 is 4 plus 6j, right? 4 plus 6j plus its conjugate 4 minus 6j divided by 2, right? So plus 6j and minus 6j cancels out here. So this is 4 plus 4, 8 divided by 2, and the first signal, that is g of 0, is equal to 4. Now calculate g of 1 in the same way. So this is x of 1 plus x conjugate of 1. Sorry, x, what is that? So second is x conjugate of 3. X conjugate of 3 divide by 2. Someone is unmuting the mic. Mute your mic. So that is x conjugate of 3. That gives me the x of 1 value is 2, and x conjugate of 3, the value is 2j whole divided by 2. So therefore the answer is, if you divide this, so you are going to get 1 minus j, right? That is g of 1. So you already solved. So similarly, so g of 2 is equal to x of 2 plus x conjugate of 2. So this is minus 2 divided by 2. So therefore this will be once again minus 2. Now finally g of 3 is equal to, so this is by 2. So I directly write the answer. So g of 3 should be 1 plus j. Therefore g of k is equal to 4 comma 1 minus j comma minus 2 comma 1 plus j. Now give me the values for h of k. Similarly, h of k is equal to what? H of k, solve for h of k and give the answer for h of k. So while calculating h of k, so to calculate h of k, so you need to perform x of k minus x conjugate of n minus k whole divided by 2j, right? So you need to use this particular formula to obtain h of k values. So if you use this, so therefore, to calculate, let me calculate the first value and then later on you calculate the rest of the values. X conjugate of 4 minus k, that remains 4 and divided by 2j. So therefore, x of 0 value is 4 plus 6j minus its conjugate, that is 4 minus 6j, minus of minus, divided by 2j. So this is plus, it becomes plus, minus of minus, right? Divided by 2j. So plus 4 and minus 4 get cancels. So therefore it is 6 plus 6, 12j divided by 2j. So j and j once again cancels. So this comes to be 6, right? So the first value is 6, followed by, similarly if you follow the same methods, so you will going to get the second value as 1 minus j, third value as 0, and the final answer, the final value as 1 plus j, right? So look at this. The beauty of this problem is we have applied a single 4-point DFT to calculate two 4-point sequences. You had x of n, you had g of n, you could calculate g of k, and you had h of n, you could calculate h of k. So there are two 4-point sequences, but instead of applying 4-point DFT twice, you applied 4-point DFT single time. Look at the computation, the simplicity in the computation, so that you can avoid those many number of complex additions, complex multiplications tasks in your what hardware. So many you are trying to reduce the complexity in the computation complexity with respect to ALU, right? Because processor, when I say that whatever the operation has to be performed by the processor inside it consisting of ALU. What does the ALU consisting of? ALU consisting of the addition, subtraction unit, and multiplication unit, and another division unit. So form, and apart from that there is a one more like logical part, like AND operation, OR operation, XOR operation, and put together I call this as a ALU. And ALU is my heart of my processor, central processing unit, CPU. Now when I give this x of n to my processor, then it has to go for many complex additions and complex multiplications inside it. So it will be naturally, it will be taking a more number of uh, time, or more number of hardwares are required to calculate or compute this x of n value. If there are such more number of values, more number of x of n sequences or too many number of same point if I'm saying same point sequences, I can club those and so that I can make my efficient computation by using this particular technique. Is this clear or any doubts here? Any doubts? Okay, good. Uh, I'll just take you to the quickly one more topic. So this is once again a same kind of topic where we have a sequence which is of 2n point, and now we need to calculate using single endpoint efficient computation of 2n point DFT, where let me assume that so this is a sequence g of n which is having a 2n length. Assume that uh, 8-point DFT. If you have 8-point DFT, 8-point sequence, I can write this 8-point as 2n, which is considering as n equal to 4, which is again a 8-point sequence itself, right? So now I ask you to find out that particular DFT using n-point DFT. You got my point? So if you have a x of n sequence, let us assume n equal to 8. Now if I want to calculate this, then what I say? I apply n-point DFT itself to calculate the x of k. Now instead of calling n equal to 8, can I call this n is equal to 2 into 4, where I call this as 4-point DFT instead of calling it as a 8-point. Here I just say it as 2n-point where n equal to 4. Now instead of applying 8-point DFT to calculate x of n, apply 4-point DFT. Apply 4-point DFT. But you should get x of k as 8-point sequences itself. Applying 4-point DFT for 8-point sequences, but still the x of k should be once again a output must consisting of 8-point sequences itself. But DFT applied is only 4-point. That is what we speak about. Given a g of length to be a length of 2n. 2n means if 8-point, so then I say that 2 into 4. If it is 16-point, then it is 2 into 8. So where you need to apply 8-point DFT to calculate 16-point DFT. If it is a 8-point sequences, you need to apply 4-point DFT to calculate 8-point sequences. So in such cases, what we do is, I have a sequences of x of n, right? This x of n sequences, which is having n-point. Now what we do is, we simply go for divide and conquer rule, as we did in case of DITFFT method, dividing a x of n sequences into even sequence and odd sequence. So this technique once again we apply to calculate a 2n-point sequences using n-point sequences. Okay. Let us see. We need to combine. So what we do is x of n, see here, g of n is the length of the sequences. We divide that g of n into even sequence and odd sequence. How do you write the even sequences of g of n? It is nothing but g of 2n. I assign this to one of the sequences. Let me call this as x1 of n. And how do you divide the odd sequences of g of n? The odd sequences of g of n can be represented as g of 2n plus 1 As you know this already, I assign this to x2 of n, right? So observe carefully if it is a 8-point sequence. If it is a 8-point sequence. Now when I divide only even sequences, what is this point? 4-point DFT. Am I right? 4-point sequence. And what about x2 of n? x2 of n is also 4-point sequences. And now you have x1 and x2 as a 4.2 4-point sequences. And in the previous example, you already did it. How do you do? Same thing. Combine x1 and x2 with a complex value, obtain the N-point DFT, and further process is very simple. You already did this particular problem. Are you getting this, guys? Very simple and straightforward. I just repeat this once again. See here. See, if you understood this concept well and good, so next concept is very simple. Assume that you have a g of n sequences which is of 8 point. Okay, g of n is equal to 8-point DFT, 8-point sequences. Now you should not use 8-point DFT. You should not use 8-point DFT to calculate the g of k. Instead, you should use 4-point DFT. You should use 4-point DFT to calculate g of k. What we do is we divide this g of n into two sequences. Let me assume x1 of n and x2 of n. So what will be the, if you divide, what will be the sequence of x1 of n? 4-point sequence. What is the sequence of this? This is also 4-point sequence. How do you divide this? Divide this in the form of even and odd. That's it. Even sequences and odd sequences. Now you have x1 of n, which is 4-point sequence, and x2 of n, which is again a 4-point sequence. Now which is nothing but two 4-point sequences. Now two 4-point sequences to obtain a single 4-point sequence, right? So that's where I just combine this x1 of n and x2 of n in the as we performed in the previous step. Once again we go for the steps that we followed in the previous stage. So that's a very simple and straightforward technique where x1 of n is nothing but a even sequences of g of n. That's why we write it as g of 2n. And x2 of n is nothing but a odd sequences of g of n. Now, if you observe x of n length, what will be the length of x of n? Obviously, if I assume this 2n, now this is very simple, n-point sequences, right? So if it is 8-point, here this will be 4-point. Now x1 is 4-point, x2 is 4-point. Now obtain the DFT of this. So that's a very simple and straightforward. Already you did it. x1 of k is obtained using this formula, x2 of k using this formula. And once again, the point is, how do you obtain the g of n values? G of n. So again look at this. This is very important here. G of n, to obtain g of k. G of k is equal to summation n runs from 2n minus 1 g of n wn to the power of 2. So this is how we obtain like coming to this point. So g of k, if you observe g of n, we told you that we need to divide this in the form of odd and even sequences. So if it is divided into even sequences, this is how we try to write the equation, right? So till now, I hope till this point, the point is very clear. Obtaining the x1 and x2 of k. So this point is clear. Now the thing is, once you obtain this x1 and x2, you need to combine them so that you will going to get g of k, which is of 8-point sequences. That's it. Okay. So for which g of k, we try to write this in the form of odd and even sequences in this form, right? So this already you know how we write these equations from the previous uh, knowledge, from the previous class knowledge. So here we take out w 2n to the power of k outside, which is out of the scope of this particular limit. So that's where this is what the simple step we do, and g of k is nothing but what? G of k is nothing but what? X of k plus w w to the power of k 2n plus this is once again can be defined as a x2 of k. So you already computed g1 of the x1 of k and x2 of k. Just multiply this twiddle factor to obtain complete g of k. So once again g of k will be running from only n point sequences, right? N point sequences, but you are supposed to obtain two n point sequences. So next half of the value will be complex the periodic or symmetric property. That is what it is going to be followed. Symmetric property or periodicity property, that's what in the first derivation of DIT FFT method, we performed this particular step to calculate the rest of the 50% of values of DFTs, that is g of k plus n. So g of k will be n values. Assume if you n value is 8, here 4 values and here 4 values are going to be separated. Then once again g of k is going to be a 4 point sequences. You will going to get 0 to 3, and next 3 to 7 sequences are obtained by g of k plus 1 sequences. Is that clear to all of you? Now what is final g of k? Final g of k is nothing but concatenation of g of k comma g of k plus n. That's it. So now this is how the complexity of the problem is going to be reduced. Is this clear? So here I'll not solve this example, but I will give it you as a assignment problem. Just solve this and see to that whether you could able to obtain the geo what is that the DFT of a given sequences using 2n sequences. So now what is the I could say that, or I could conclude computation of, by previous concept I say that it is a computation of 2 n-point DFT using single n-point DFT. Okay, the sequence is only one. How many sequences? Only one sequences, g of n, which was 2 n-point sequence. Computation of its DFT using n-point DFT. Okay, previous of this was computation of two real sequences, using single n-point DFT. Okay, two real sequences of n-point, right? Which means that x1 of n was n-point DFT, n-point sequence, and x2 of n it was one more n-point sequences. So put together I apply only once to calculate the n-point DFT. I apply only one time n-point DFT to calculate x1 of k and x2 of k, right? So with this, I'll just give you one of the example. Just note down. Find the 8-point DFT of the sequence. Find the 8-point sequence DFT of the sequence. V of n is equal to 1, 2, once again 2, one more 2, 0, 1, 1, and 1 using a single 4-point DFT. Using a single 4-point DFT. Okay, what you are supposed to do? You need to separate this as x1 of n, which is nothing but v of 2n, which is nothing but a even sequences. So when I say that even sequences, so this is the even sequence 1 and 2 and one more 2, the 0 and 1, right? Next, x2 of n is equal to v of 2n plus 1. So odd sequences of this, how do you obtain? So that is again 2, 2, 1 and 1, right? So you need to obtain this by combining, putting them in the form of complex value, that is x1 plus j times x2 of n. So obtain its DFT here. Now after obtaining the DFT, you are supposed to obtain the values of x1 of k and x2 of k. Now after obtaining the values of x1 of k and x2 of k, you are supposed to obtain the value of v of k. V of k, that's where you are supposed to use the formula that what we derived right now. Just okay. So that is V of k is nothing but x1 of k plus w2n k x2 of k. Fine. So this is to find out the value of V of k, and again V of k plus 1, k plus n. So that next half of the values. So that's how do you find out x1 of k minus w2n to the power of k x2 of k. So this is the formula to find out the value of first half and next half. Combine them, combine them, that's it, to get a final v of k, to get a final uh, v of k, to get a final value of k. So you need to concatenate both the values, first half values and next half values. That's it. This is the step that you are supposed to follow. I hope you solve this example on your own. There is no much complexities involved as such, right? So this completes your the second unit. So in the from the next class, we'll start with the unit 4. It is design of analog filters, and that particular chapter is quite. Uh, you need to have a more attention. Don't miss out the sessions for that particular matter, because from once I start my filter design with respect to analog, if you know unit 4 well and thorough, sorry, yeah, unit 4 well and thoroughly, then if you know how to design analog IR filter, then only you can design the FIR filter. Unless and until you understand the unit 4, you cannot understand the unit 5 chapter, that's for sure. So because 50% of the problems, 50% of the problem to be solved in the unit 5 is depending upon the how you understand in my unit 4 chapters. Okay, so this is a very continuation part. Okay, till here I can say that it was totally independent topics. But from the next chapter onwards, the unit wise to the next unit are totally depend from one unit to another unit. With this, let me conclude the thank you, and